Hello, welcome to this information session at the School of Architecture and Design at the New York Institute of Technology. My name is Pablo Lorenzo-Eiroa, and I am the director of the MS in Architecture and Computational Technologies. And I would like to first start by thanking our Dean Maria Pervelini and our Associate Dean Anthony Caradona for not only facilitating this information session, but also for all the contributions in the development of this new and exciting program. I'm going to start sharing information about this program so that you are familiar with what this is about. The program is a new program that has as a core the question of what is the emergent architecture of information. And one of the objectives is to expand design authorship to new media and new mediums. The core of the program is going to be based on history, theory, and criticism of representation and technologies, using scientific evidence-based design, but also addressing new aesthetic means of designing space and addressing space through ecological terms by applying the latest technology available, but also innovating in terms of new technology. The semester map is pretty simple, but it gives you a lot of flexibility as you can combine the different areas of focus with each other, or focus in a particular area of expertise to acquire a certificate. So the first semester is 12 credits. The total program is 30 credits. The first semester is 12, the second is 12, and the third summer session is 6 credits. The first semester, obviously, in architecture, we have the design studio, which is going to work as our applied base to integrate all the knowledge of the different areas and the different courses. We're going to also have a studio workshop in parallel to the studio, which is going to serve not only as a leveling platform, but also to expand some areas that the other courses cannot give. And if you don't have any expertise in computation, or you have little expertise in computation, you do not have to worry, because we're going to use this studio workshop in order to level your skills in order to be able to address the other seminars that are more elevated and complex. Second semester is going to be, the studio is going to focus on fabrication and robotics, and you can either do fabrication or robotics as an elective seminar, or computational design, the second version of it. And the third term is very exciting because it's going to be in, the first 2 terms are in New York City. The third term is going to be in Long Island, in Old Westbury. And the advantage of that is that we have a bigger fab lab and we have more room to do one-to-one experimentation, such as, for instance, developing facade prototypes or a one-to-one pavilion with the different students, all the students working together if there is that interest. The first focus area is a computational design, in which we're going to be looking at artificial intelligence, machine learning, different types of simulations, and also in relationship to virtual reality, augmented reality, and so on. There are different aspects that we're going to be looking at. Here you can also, on our website, you can download these slides, which is available under the program brochure, or information, program information brochure, program summary. In which you can look at the different aspects that the first concentration area computational design is going to touch, right? There are many interesting aspects that we're going to be looking at, including not only including artificial intelligence, but for instance, blockchain as one of those technologies that is actually presenting radical innovation to many disciplines, not only to architecture. As I said before, we're going to base everything on Python in the first semester, and the second semester in computational design. And in terms of robotics, we're going to base robotics in terms of KUKA PRC, because we have the KUKA Agilus robots. We have 3 of them that they are designed to interact with each other. And I'm going to explain that later about our facilities. We're also going to be looking at history in a scientific way by 3D scanning buildings and monuments, or spaces that you are maybe interested in, and developing alternative histories and alternative theories. But also we're going to deconstruct the systems of representation. So for instance, how software works and why the different softwares have different ideologies of representation of space. We're going to look at different types of algorithms and different types of computational structures. We're going to analyze them, and we're going to also try to displace them in order for the students to create their own systems of representation and their own algorithms. So you're going to be given a base normative algorithm, understanding a certain technology. Also, we're going to be doing simulation of different types, environmental simulation of different types. And we're not only going to be reading interiors, but also exterior spaces, and perhaps a little bit of an urban morphology and the relationship between architecture and its environmental context. We're also going to be working the second focus area. There are 4 focus areas, which are reduced to 3. The focus area number 1 is computational design that I just explained. The second focus area is robotics and fabrication. And the third area is materials. But robotics and fabrications is split into 2. There is robotic interactivity and also robotic fabrication. In robotic interactivity, we're going to learn how to work with Raspberry Pi or Arduino, depending on the faculty, in developing interactive physical computation systems. So for instance, to regulate light, but also to sense reality, to map reality through our own data acquisition systems. That's why we're going to be looking at these problems, sensor design, developing in interactivity, but also immersive environment, and to think, for instance, about data link and data sensing. In addition to that, we're going to, if you are interested, some of the students are interested, the second part of the second area of focus, which is robotic fabrication, we're going to be looking not only at the technology of fabrication available through robots, 3D printing, and different types of printing methods, such as Kevlar printing with the fibers, or concrete, developing our own concrete mixture and assigning them and building them through robotics. But we're going to think about robotic fabrication as a design process, thinking that there are things that we can edit in the relationship between the original design and the way the design is being built, and to do a loop back and forth between fabrication and design, thinking that fabrication itself can be an area of design and an area of expertise in terms of design, developing a feedback between automation, fabrication, simulation, and design feedback. So we're going to be thinking about robotic systems for building and drawing, and a relationship between the 2 to inform each other. So for instance, in this diagram that is very clear, the informed 3D printing result is not only a simulation in terms of structure and a design simulation, but it's an optimization that loops back and forth between the possibilities of the material and the material behavior in terms of structural stress. So we're going to loop back and forth between structural design, design optimization, simulation in virtual terms, but also physical experimentation, and be looping back that information to feed into the design process. So for instance, the same surface can be built in different ways. We're going to implement artificial intelligence in terms of looking at the behavior of the surface under stress through structural simulation of different kinds, but also implementing ways of depositing the filament, the 3D printing filament, to not only optimize the material, but also to find structural stress in the design of the material. So the form is not only informed by the design of the original geometry, but the original geometry is transformed by the fabrication and materialization process, including the possibilities and the different axes of the robotic systems that we're going to be working with. So here are examples of that type of optimization. We're also going to look at the behavior of the material while it is being printed or CNC'd or transformed, to integrate that information and change the design. One of the objectives is actually to develop new ways of constructing. This is a robotic fabrication machine that we developed in my office, earchitects.net, that you can check it out. And what we did was to develop a site-specific 3D printer that can be adapted to any situation, does not need this frame, is cable-driven. And the idea is that the students in these programs think about that type of innovation and that they may also themselves be able to create their own robots for fabrication. Of course, I'm talking about the third semester after you acquire certain knowledge. The third area of focus is materials design, and is related to thinking about material behavior, robotic materials that themselves, the materials can be programmed to react to certain inputs such as temperature, touch, different types of interactivity and different types of lifespan. Composite materials, biomaterials, and in overall designing your own material for 3D printing or with other types of technologies. As I said before, the project-based learning studio is going to be located in Old Westbury. Is the third term. The first 2 terms are in New York. The third term is in Old Westbury, which is 1 hour away from New York City. And we're going to integrate all the knowledge in terms of kind of thesis for the students to integrate everything, but also to interact with each other, so we can decide whether we do a single pavilion with all the students together, or if each student develops a little bit of a space. The facilities are very good. They're top of the art. They are competitive with all the fab labs in the area. Actually, I think we have better facilities than our competitors. And the director of the facility, the director of the digital architecture sequence is Dustin White, who is supervising the fab lab and the relationship between the technicians that are going to assist the students in terms of the fab lab. We also want to have research, startup, tech transfer, and patent. Then we have, of course, public events and programs such as exhibition, lectures, and other types of events. This is a participation on the Biennale of our students from last year, in which we invited a series of international jurors to critique the work, but also the students were able to develop interactive architecture and physical fabrication items that are currently exhibited at the Venice Biennale in Venice, in Italy. The exhibition carries exhibition and lecture series is very comprehensive. We invite the most innovative architects that are working at the frontiers of innovation all over the world. Many of them, they know us, and we have fluent relationships with them, including our participation in the Digital Futures event in Asia, or with Tongji University, or for instance, participating in lectures and events and symposium developing in coordination with other universities. In terms of the career options that this program will allow you to do or to explore, it's very interesting because it allows you to do a range of things that are probably unparalleled, right? You can work as many different things, not only as an architect or as a architect, design, build, fabricator, or develop your own fab lab, but you could also think about environmental design, urban design, university professor, research, computational designer, data designer, right? There's a full of things that you can do. I'm very interested in the notion of an entrepreneurial architect, developing your own projects. So thinking about a fabrication laboratory, design architect, or thinking about producing your own form of business, to me, is an interesting aspect today. The faculty includes, of course, myself. I'm the director of the program. I was trained in Argentina. I studied at Princeton University with a Fulbright scholarship. And I then worked with Peter Eisenman, and I have extensive experience on computational design and robotics and fabrication, different type of collaborations and projects. We also have a Professor Christian Pongratz. That Christian is actually working on a partner program that is going to be in tandem to our program, which is Architecture, Health, and Design. And Christian Pongratz is an expert in robotic fabrication and fabrication in general. And we'll also be working on the health and design of health prototypes, health for the body, so issues that are related to also materials, because we're going to be sharing the materials course that is one of the electives in our programs. Professor Marcella Di Signori is an associate professor and also director of the MS in Urban Design, which is going to be helping us in different ways. And Professor Tom Berberes, who's also currently teaching an urban design program, but also is a guest reviewers in our program and has also been responsible for co-developing this program. As I mentioned before, Dustin White is the director of the Technologies and Fabrication area of our School of Architecture and Design, and is usually involved in fabrication projects, and his expertise is in robotic fabrication. If you want more information, you can visit our website. We have a blog in which you can look at student work, faculty work, and the specificities of our fabrication lab and machinery is available. And if you need financial aid, you can also explore the different possibilities that NYIT can offer you. Thank you for your attention, and please feel free to reach us if you have any questions. Thank you, and we look forward to having you in our program.